For today's unit, we're going to be talking about electricity, and more specifically static electricity and how charges transfer between objects. So take a moment here to list as many items as possible that you encounter in your everyday life which use electricity. So cell phones, lights, computers, your Chromebook. We use a lot of different devices that use electricity. So in this unit, we're going to be discussing electricity, how charge transfers, how we can calculate current and voltage, and actually make circuits in our mini houses we're going to be designing. So what is electricity? So all electricity is the flow of electrons or charge. Now, electricity is considered a secondary energy source. So we have to use another form of energy to make electricity. So we either burn coal or oil or natural gas or do a nuclear reaction to make or generate electricity. So it's a secondary source. So we need to use some other fuel to make electricity. So when we have an imbalance of charges within a material or on the surface of the material, we get something called static electricity. So this has maybe happened to you like on the winter day, you put on a sweater and all of a sudden your hair is sticking up, or your hair gets attracted or clings to a balloon, or your clothes or dress cling to you. So it just happens because there's an imbalance of charge. So one has some negative charges, one has some positive charges, we get that imbalance. So lightning is a good example of static electricity. So all it is a large discharge of built up electrons. So this picture you want to draw in your notes here. So what happens in the cloud is that currents are flowing in the cloud start to separate charges. So we have this positive charge that builds up on top, and we get this negative charge that builds up on the bottom. And eventually it builds up so much negative charge that that cloud is attracted to the earth, which is a big neutral object. And so we get that connection between the positive and the negative, and we get that discharge. So we've talked about electrons. Electricity is the flow of an electron, but where do those electrons come from? So charge, we measure in a unit called a coulomb, named after a scientist, so it's a capital C. In the equation, though, charge is symbolized with a lowercase q or a capital Q. So where does that charge come from? So charge comes from the atoms that make up our objects in our everyday life. So electrons are located outside the nucleus in the electron cloud, shown here in the picture. They have a mass that's pretty small compared to a proton. It has a charge of -1. The other charged object in our atom is the proton. Proton is located in the center, which we call the nucleus. It has a mass that's quite larger than the electron, but still really, really small. But has a charge of +1. The other thing in the atom is a neutron, has no charge. So when we talk about electricity, we want to talk about the charged things. So the electron with the -1 charge, the proton with the positive charge. And now when something gains extra charges, what we're gaining is electrons. So electrons are what move around between our atoms. So we can gain electrons, we can lose electrons. The protons are held pretty tightly in the center, so we don't gain or lose protons unless we're doing like a nuclear reaction. So if something becomes charged, it's gained electrons or it's lost electrons. So when charges interact, we can get some unique forces to occur. So when we have opposite charges, so positive and a negative, we're going to get an attraction. So you probably have heard the term opposites attract. And so that comes from an actual science understanding. So positive and negative charges are going to attract one another. Same thing with a neutral charge. So if we have a positive charge and a neutral charge, we're going to get some attraction. Same if with a negative and a neutral charge, we're going to get attraction. So as long as one of our objects is charged and the other one is a different charge than that, we're going to get attraction. So it can be positive and a negative. It could be a positive with a neutral or a negative with a neutral, and we're going to get attraction. If charges are alike, meaning they're the same, we're going to have a repulsion. So they're going to push apart. So two positives next to one another are going to repel. If we had two negatives next to one another, they're also going to repel. And then the last type of interaction we could have are two neutral charges. So two neutral charges, nothing's going to happen. There's no force between them. So no attraction, no repulsion. So what kind of objects can become charged or hold a charge for us? So objects are charged because they transfer electrons. So electrons move from one object to another. So one becomes negative, one becomes positive. The thing that gains electrons should become negative. The thing that loses electrons becomes positive. So again, protons don't move around in our atom. So only the electrons move around. So you have a couple different types of materials. And how do they hold a charge or not hold a charge? So insulators do not like to lose their electrons. So electrons are held pretty tightly in insulators. And so electrons don't move. So no current or electricity can flow through an insulator. So rubber, plastic, glass, wood, air, they're all really good insulators. So if you've ever noticed like our power cords and stuff, they're always coated in plastic. So that prevents the charge on the inside escaping. Conductors are the opposite. So conductors allow electrons to move really easily. And these are metals. So like copper that we use in our wiring, gold, aluminum, any metal is going to be able to conduct electricity. So they allow the electrons to move around. The other type of material we have is a ground. So a ground is what we consider a large neutral object. So it can absorb a whole bunch of extra charge and not become actually charged itself. So when we ground things like in our houses and stuff like that, we're actually connecting it to the earth. So earth is the ground. So your house should be grounded in case it gets struck by lightning. The electricity safely goes from wherever it struck to the ground. Your plumbing is also grounded in your houses. So again, if something strikes your house, the lightning strikes it, has a safe way to get out. The symbol for a ground is shown there in the picture. So insulators don't allow electricity to move through it. Conductors allow electricity to move it, and ground is our big neutral object. So when you're looking at an outlet, the ground is that kind of circular looking port. So how do we get something to be charged? There's three different methods to charge an object. So the first is by friction. So you're rubbing two objects together. One of them becomes positive, one of them becomes negative. So if you've ever taken a balloon, rubbed it in your hair, it becomes charged. So your hair becomes positive because it's losing electrons. The balloon becomes negative because it gains those extra electrons. So when you rub two surfaces together, you get that charging. The next method is charging by conduction. So here we take an object that's already charged. We bring it next to an object that is not charged, that's neutral, and those electrons move towards it. So here you can see in the end, some of the electrons have been transferred to the dome. So charging by conduction, charging a metal by touching it with a charged object. And then the third method to charge an object is by induction. So here the objects get charged, but they're not touching one another. So here we have a can, it's neutral, positive, negative, positive, negative, positive, negative. So they all cancel one another. So it's a neutral object. If we bring next to it a charged object, so here this rod is positively charged, what happens is the charges start to separate in our can. So the negatives get kind of pushed towards the surface that's next to the positive. The positive charges get repelled or pushed away. So the can doesn't actually lose or gain charge, they just start to separate So the can doesn't actually gain or lose any charge, it just starts to separate. So if we were to bring a negative rod next to it, the positives would get pushed towards that rod, the negatives would get repelled or pushed away from that rod. And so the can would start to move towards that rod because of that separation in charges. So let's look at a couple of simulations here to show these different methods of charging. So here we can show some charging by induction. So first we're going to charge this balloon by friction. So we're going to rub it against our shirt here. So we're charging it by friction. Okay, so our balloon is now charged. So if we bring it towards the wall, we see that those negative charges get pushed away, and the positive charges are staying in place. But the negative charges get kind of pushed away. So that's induction. So our balloon would stick to the wall. So here we can use John Travoltage here. We can charge him. So you maybe have done this at home before, walked across a carpet with your feet. So as you're doing that, you're charging yourself by friction. Okay, so now John Travoltage here is charged. Now we're going to charge the door by conduction. So as he touches the door, we see that he conducts electricity and charges the door. So charge by friction, by rubbing our foot across the ground. And then charge the door by conduction, by touching it.